Hello everyone, welcome back to Blessings Education Support. Now we have completed our full chapter by chapter explanation of IGCSE Chemistry on this channel. So from today we are moving on to the next and most important stage, which is past papers. In this series, we won't just look at the answers, we will go through each question with a proper explanation so that your concepts become clearer. That way, even if the examiner tests a different angle from the same topic in the exam, you will already know how to approach it and what the answers should look like. Before we begin, a quick note along with these free videos, we also offer online group classes for all IGCSE subjects biology, chemistry, physics, and other with our experienced tutors at a very reasonable rate for students anywhere in the world. Our tutors takes you through every chapter step by step until the concepts are fully clear. If you would like to join, message us on our WhatsApp number or you can also book classes directly on our website blessingstutors.com. Now let's get started with our first past paper. As you can see, this is chemistry paper 2 multiple choice question extended and May June 2025. So here we can see that the examiners has given us 45 minutes and the total mark of this paper is 40. So let's start. The first question is a gas is placed in a sealed container with a fixed volume. The gas is heated. Which statements are correct? So the options given are number 1, the gas molecules move around faster. Number 2, the gas particles collide with the walls of the container more frequently. And number 3, the pressure in the container decreases. Here our answer choice is A, which contains statement 1 and 2. So statement 1, the gas molecules move around faster and the gas particles collide with the walls of the container more frequently. Now in case of gas, okay, and the scenario that it is in the sealed container with the fixed volume. So our explanation is that heating on a gas inside a sealed container increases the kinetic energy of the molecules, which causes them to move faster. As a result, the particles collide with the container walls more frequently, which increasing their internal pressure as well. Hence, the best answer for us is the gas move faster and the same explanation which is given here due to sealed container kinetic energy of these molecules increases, all right? And the second one is also that the gas molecules collide with the walls of the container, that also again mentioned here that as a result the particles collide with the container walls more frequently. Let's move on to our next question, which is a sample of ethanol is heated at a constant rate. The heating curve for this sample is shown, and you can see in this graph that how from 1 to 2 the gas particles are moving with the increase in temperature, and then from 2 to 3 it is constant. Again from 3 till 4 it is increasing. Again from 4 till 5 it is constant. And then from 5 to 6 it is increasing. Hence, we need to find out by looking to this graph that which statements about the heating curve is correct. The options that are given to us is A, ethanol changes its physical state between 3 and 4. B, ethanol condenses between 2 and 3. C, energy is absorbed between 3 and 4 but not absorbed between 4 and 5. And the D, which is more energy is absorbed between 4 and 5 than between 2 and 3. So what its explanation is that the region from 4 to 5, this represents the boiling phase, which requires a substantial amount of latent heat to completely break the intermolecular forces between ethanol molecules. This phase change requires significantly more energy than the melting phase that occurs between 2 and 3. So you can see here the region 4 till 5, the constant phase. This region represents the boiling phase. And here if it wants to move from 5 to 6, it needs a substantial amount of heat to completely break the intermolecular forces between ethanol molecules. Ethanol molecules was also given in our question. That is a sample that is given to us and that is heated at a constant rate. Hence, the best explanation for this answer is more energy is absorbed between 4 and 5 than between 2 and 3. As you can see that 4 and 5 has higher temperature as compared to 2 and 3. If you consider the time on the horizontal axis, you can see that 4 till 5 is taking a longer time as well because it's a boiling phase and it needs a substantial amount of energy to completely break the intermolecular forces. It is very important at this stage that you understand the concept, and it's also very important, as I mentioned earlier, that the question can be asked in different form. So if the concept is clear, whatever sample changes might can come in the exam, you will be able to identify the correct answer. All right, now let's do with question number 3. Which atom has an equal number of protons, neutrons, and electrons? Now, out of these options, our answer is nitrogen 14. What is the logic behind? As you can know, that nitrogen 14 atom has an atomic number of 7, which means that it possesses 7 proton and 7 electrons. If you subtract the atomic number from its mass number of 14, it yields exactly 7 neutrons, making all of them 3 quantities equal. Hence, the same option is given to us here in the exam, that in the examination question, that the atom should have equal number of proton, neutron, and electron, and that condition is satisfied when we consider nitrogen 14. None of the others can give us the same scenario answer. All right, now let's move to question number 4. All right, so it says the only naturally occurring isotopes in a sample of europium are EU-151 and EU-153. This sample is europium, has a relative atomic mass AR of 152. Now, what is the question here? That what is the percentage of EU-151 present in this sample to the 3 significant figures? In order to answer this, we have the logic that since the relative atomic mass of the sample is exactly 152, which is given to us, which lies precisely halfway between the isotopic masses of 151 and 153, the two isotopes must represent in equal amounts. Therefore, the percentage of europium 151 is exactly 50%. Therefore, we chose our answer B, which is 50%, based on the logic that we have explained. Now let's move on to question number 5. So it says which statement about the potassium chloride is correct. So number A, which is option given to us, it has high melting point because it is a giant structure with strong covalent bonds. Number B, it conducts electricity when solid because of its oppositely charged ions. Number C, it conducts electricity when molten because its ions can move. And number D, it is insoluble in water because of its strong bonding. So our answer is it's correct. It's conduct electricity when molten because its ions can move. The logic behind this potassium chloride question is that potassium chloride is an ionic compound that forms a rigid giant lattice structure where ions are held firmly in place when solid, and then when melted into a liquid state, these ions become free to move and carry an electrical current. That is the reason that same match with our option C, which says that it conducts electricity when molten because its ion can move. All right, let's go to our next question. Which dot and cross diagram shows the outer shell electron arrangement in a molecule of nitrogen? All right, now we have different nitrogen molecules presented here. Our answer is B. what is an explanation of this is a nitrogen molecule contains a triple covalent bond, meaning the two nitrogen atoms share three pairs of electron in their overlapping outer shells. So, this leaves one unshared lone pair of electrons on the outer edge of each nitrogen atom to complete their octets. Hence, this explanation goes to option B. Now let's move on to question number 7. It says which statement about silicon 4 oxide is correct. The options that are given to us is number A. It contains silicon ions and oxide ions arranged in a giant lattice. Number B. It is used in electrical circuits because it can conduct electricity. Number C. Its bonds can each contain one shared pair of electrons. And number D, its atoms are arranged in the same way as the atoms in graphite. Here our answer choice is its bonds each contain one pair of electrons. What is an explanation of this? Silicon 4 has a giant covalent structure where every silicon atom is covalently bonded to 4 oxygen atoms, and each oxygen atom is bonded to 2 silicon atoms. Each of these individual linkages consist of a single shared pair of electrons. Let's move on to our next question now. So here the question says 3 organic molecules are described here. The molecular formula of propanoic acid is given. The molecular formula of lactic acid is given to us. And a glucose molecule consists of 6 carbon atoms, 6 oxygen atoms, and 12 hydrogen atoms is given. Now they're asking which molecules have the same empirical formula. Here, option number A is propanoic acid, lactic acid, and glucose. Number B is propanoic acid and lactic acid only. Number C, propanoic acid and glucose only. And number D, lactic acid and glucose only. Our answer is lactic acid and glucose only, which is option D. Now let's see its explanation. Lactic acid and glucose both have hydrogen to carbon and oxygen ratio that simplifies to CH2O. Now, propanoic acid cannot be simplified to this same ratio, meaning only lactic acid and glucose share the same empirical formula. Now let's move on to our next question, which is calcium carbonate reacts with dilute hydrochloric acid. So the equation is also given to us for this question. After this, they are saying 1 gram of calcium carbonate is added to 50 centimeter cube of 0.0500 mole per decimeter cube of hydrochloric acid. So the question is which volume of the carbon dioxide is made in this reaction? Our answer choice is A, which is 30 centimeter. The logic behind is that hydrochloric acid is the limiting reactant in this setup, provided 0.0025 moles of acid to the reaction. According to 2:1 stoichiometric ratio, in the balance equation, this produces 0.00125 moles of carbon dioxide, which occupies 30 cubic centimeters at room temperature and pressure. Alright, now let's move to our next question. The diagram shows the electroplating of a steel project, and as you can see here, we have a steel object in the diagram, and on the left hand side we have copper electrode given. The solution is aqueous copper 2 sulfate, and then it is connected with the power supply with the charges mentioned. Now the student makes 3 statements. The steel object turns a reddish brown color. The aqueous copper 2 sulfate changes to paler blue color, and the copper electrode becomes thinner. Which statements are correct? The options are given to us where the correct option is C, 1 and 3 only. What is the logic behind? The logic is that during the electroplating process, copper ions from the electrolyte deposit onto the negative steel cathode, coating it in a reddish brown layer of copper metal. To replenish these ions, the positive copper anode dissolves into the solution, causing it to become thinner over time. Alright, so our answer choices are 1 and 2. So number 1 is the steel object turns a reddish brown color as mentioned in the explanation, and the copper electrode becomes thinner. Alright, now let's move to our next question, question number 11. Alright, it says concentrated aqueous solution of sodium chloride is electrolyzed using inert electrodes. Now, which equation shows the correct ionic half equation for the reaction at the anode? So, we have been given 4 choices where our correct answer is B. And the explanation to this is during the electrolysis of concentrated aqueous sodium chloride, negatively charged chloride ions are attracted to the positive anode. At this electrode, they undergo oxidation by losing electrons to form diatomic chlorine gas. All these concepts of oxidation and the others that are described before are discussed in detail in our videos where we have explained each and every chapter of chemistry. So you can go back to those videos and refer them in case any concept is missing. All right. Next question is which equation represents the overall reaction in a hydrogen oxygen fuel cell? So our answer is option A. 2H2 plus O2 gives 2H2O. The explanation of this is that the overall chemical reaction inside a hydrogen oxygen fuel cell involves the exothermic combination of hydrogen gas and oxygen gas. This redox process directly generates water as the sole chemical byproduct alongside electrical energy. Our next question is question number 13. It says water is added to anhydrous copper 2 sulfate in a test tube. Now the mixture becomes hot. So which type of reaction and reaction path diagram apply to this reaction? Here we have given options. Option A endothermic, option B again endothermic, option C exothermic, and option D again exothermic. So our answer is C exothermic. The reason here is the observation that the test tube becomes hot indicates that the chemical reaction is exothermic. So it becomes hot, so of course the energy or the heat is releasing outside. So the same logic is mentioned here that the heat energy is released to its surrounding. Then in an exothermic reaction pathway diagram, the products contain less chemical energy than the initial reactant. So our answer choice C exactly matches with the explanation. So this is the correct answer. Let's go to question number 14. All right, it says the equation represents the reaction between ethanoic acid and ethanol. The equation is given to us, and then we have to identify that which type of reaction does it shows. Our answer is reversible reaction. The explanation to this is that the chemical equation features a reversible equilibrium arrow connecting the reactants to the product. So this symbol indicates that the forward esterification reaction and the reverse hydrolysis reaction occurs simultaneously. All right, now let's go to our question number 15. Here it is given to us a graph. So the graph shows that the results of adding excess calcium carbonate to hydrochloric acid at 50 degrees centigrade and at 30 degrees centigrade, only the temperature is changed. So now they ask us that which rows describe the reacting particles at 30 degrees centigrade compared to those at 50 degrees centigrade. So in our table, the options are given alongside the heading, frequency of collision between particles that we have to look into. And we also have to see that what is an average kinetic energy of the particles. Here our choice is D. So frequency of collision between particles is lower and average kinetic energy of particle is also lower. Now the explanation to this is at a lower temperature of 30 degrees Celsius, the reacting particle possess less thermal energy and move more slowly. This reduction in energy results in a lower average kinetic energy and a reduced frequency of collision between the particles.